I, Neha Thakkar, Assistant Professor in CSC IT Department at New LJ Institute of Engineering and Technology. Today we'll discuss about one of the topic of first unit, that is beta function, right? And another is also there, that is gamma. Then we'll see what is the relationship between beta and gamma function. So basically the main use of these functions is to solve the integration problem, right? So first we'll go for what? Beta function. So beta function definition is the integration 0 to 1, right? X raised to m minus 1 into 1 minus x raised to n minus 1 dx. This integration is there for two variables, that is m and n. The condition is that both must be greater than 0. So this is called a beta function for this variable. It can be denoted by beta mn. So we can write that beta mn equal to integration 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx for mn greater than 0. So basically what happened here, the function is represented in terms of what? Integration, right? The function is represented in terms of integration. So here two variable m and n, and the limit is fixed, that is 0 to 1. So normally that will be used for what? To show the area. Suppose this limit is there, or suppose a and b. So what happened? It will shows a area like this. Suppose x equal to a and x equal to b. So obviously this will be what? Area. Now if we are going to change the value of this limit, then obviously the area is supposed to be changed. But now the limit is fixed and two variables are added, that is m and n. So if we are going to change the value of m and n, right? If m and n are supposed to be changed, then also the area is going to be changed. That means this time the area will be depend upon two variables, that is m and n. So that we have included, right? So some of the properties are also there of beta function. So properties are, first one is beta mn equal to beta nm. That means what? You can replace m with n, so that we can say what? It's a symmetry. The next one is beta mn equal to integration 0 to infinity x raised to n minus 1 upon 1 plus x raised to m plus n dx, right? X raised to n minus 1 upon 1 plus x raised to m plus n dx. Now the same thing can be represented with what? As the first property, m can be replaced with n. So here also we can write what? 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx. So this is the second property. Now third one is beta mn equal to 2 integration 0 to pi by 2 sin theta raised to 2m minus 1 cos theta raised to 2n minus 1 d theta. So this is also one of the property. Now in some book it may be written as a what? Instead of this it can be sine raised to 2m minus 1 and theta. So that is also a true one, right? You can write in a both way. Now we'll prove this property one by one. So first we'll go for this property, that is symmetry. So we'll see that one. So first property is beta mn equal to beta nm. So by definition we know that, right? First we'll start with what? Definition of beta mn. So by definition the beta mn equal to integration 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. Right? This is the basic definition. Now, we know one rule, that is what? Integration 0 to a fx dx, it can be rewrite as 0 to a f of a minus x dx. That means what? These both are same, right? So that we can apply in our function. So we can write what? Beta mn equal to 0 to 1. Here a, here what? 1. So it can be 0 to 1. Now f of a minus x. So a minus x, that means what? It is 1. So we can write what? 1 minus x. So here x raised to m minus 1, instead of x we'll write what here? 1 minus x raised to m minus 1. Right? Again here the x, so we'll replace it what? 1 minus x whole raised to n minus 1 dx. Now just we will simplify this one. So what happened? 0 to 1, 1 minus x raised to m minus 1, this 1 minus 1 plus x. So this one is supposed to be cancel out. So we can write what? Directly x raised to n minus 1 dx. Now compare it with the basic equation. So again we can rewrite it like what? 0 to 1, x will be right first. So x raised to n minus 1, 1 minus x raised to m minus 1 dx. Now if we'll compare this equation with this one, right? So you will get what? Here n minus 1, here m minus 1, and the second one m minus 1, here n minus 1. So we can write what? This is beta mn. So this can be written what? Beta n m. That means you can replace n with m. So both are same one. So that is your what? First property, beta mn equal to beta nm. Now we'll prove the second property. So second property, that is beta mn equal to 0 to infinity x raised to n minus 1 upon 1 plus x raised to m plus 1 dx, right? So again we'll start with the basic equation of beta function. So beta function equation is what? Beta mn equal to integration 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So that is our basic equation. Now see the result. What we want? X raised to n minus 1 upon We want this in denominator, right? 1 plus x raised to m plus n. So that means we have to do the replacement. That means instead of x, we'll put a something. So assume that put x equal to 1 upon 1 plus y, right? So we'll get what? Dx equal to, just will do what? Differentiation. So it will give you what? 1 upon 1 plus y. So differentiation of that will become what? Minus 1 upon 1 plus y square dy. Now if you change, that means if you put x equal to 1 upon 1 plus y, so obviously the limit is supposed to be changed, right? Because here 0 to 1, that is for x. So we'll do what? Find the limit. So for limits x equal to 0, when x equal to 0, so put into the equation x equal to 0. So at that time you will get what? X equal to 0. So that will become what? 1 plus y equal to 1 upon 0. So y will become what? Infinity. Now when x equal to what? 1. So when x equal to 1, the y will become what? 0. So this limit we are going to use when we replace x with what? 1 upon 1 plus y. So again we'll start with the basic equation. Just we'll put value of x and limit into our basic equation. So beta mn equal to, that is what? 0 to 1. When x equal to 0, y equal to infinity. So obviously it is what? Infinity to 0. Right? The next thing is what? X raised to m minus 1. So instead of x, we'll put 1 upon 1 plus y. The whole raised to m minus 1. Now 1 minus x. Again 1 minus, instead of x, 1 upon 1 plus y. And the whole raised to n minus 1. Now dx. So instead of dx, we can put this thing. So that is minus 1 upon 1 plus y the whole square and dy. Now we'll try to solve this equation, right? So infinity to 0, this 1 raised to m minus 1, that is 1. So 1 upon 1 plus y raised to m minus 1, right? Here for this we can take a LCM. So it will be what? 1 plus y minus 1. So obviously this 1 is supposed to be cancelled out. So that will become what? Y upon 1 plus y raised to n minus 1. Now this. So that is minus sign, right? So whenever the minus sign is there, now in our equation, see what we want? 0 to infinity. And here that is infinity to 0. So we can remove this minus sign and we can change the limit. So we'll remove the sign and we'll change. It will become 0 and that will become infinity. So it can be written as a 1 upon 1 plus y square dy, right? Now you can see that in denominator 1 plus y raised to something, again 1 plus y, right? This can be separated. So we can write what? This y raised to n minus 1 and this 1 plus y also raised to 1 n minus 1. Again the third one, 1 upon 1 plus y. So you can see that 1 plus y, 1 plus y, 1 plus y. So we can do what? We can plus this thing, right? Whatever in the power, that can be. So it can be rewrite as what? 0 to infinity. Now here only y raised to n minus 1. So what happened? Here 1 plus y. Now addition of all the powers, right? So you will get what? M minus 1 plus n, again minus 1, and plus 2. So you can see that minus 1 minus 1, that is minus 2, and plus 2. So that things is supposed to be cancel out. So you will get what? M plus n. So again we can rewrite 0 to infinity y raised to n minus 1 upon 1 plus y raised to m plus n. So just compare it with your property. So you will get what? Y raised to n minus 1. So in that, again this is what? Y. Okay. So at that time you will get what? This thing. That means what? Y raised to n minus 1 upon 1 plus x raised to m plus n. Obviously the dx is supposed to be there. Sorry, here it will be dy, right? Here also a dy. So what happened here? N minus 1. So the second equation. That means what? Instead of y, you can write down a x. That is the basic one. Instead of y, you can write down x. So rewrite it, or here we write 0 to infinity x raised to n minus 1 upon 1 plus y. So 1 plus x, right? 1 plus x raised to m plus n and dx. So that is your first one. So this is about what? Second property. Beta mn equal to 0 to infinity x raised to n minus 1 upon 1 plus x raised to m plus n dx. Now instead of x we can also write what? N. So that is about the second property of beta function. Now we'll see the third property. Third property is beta mn equal to 2 integration 0 to pi by 2 sine theta raised to 2m minus 1 cos theta raised to 2n minus 1 d theta. So in this also we'll start the definition with what? Beta function. So by definition, beta mn equal to integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. Now again same like a previous property, right? We'll put what? X, or we'll replace x with something. So here we want what? Sin theta. So if you will replace x with the sin theta, so will become what? Sin theta raised to m minus 1. But in that you want what? 2m minus 1. That means with m you require 2. So we will replace x with what? Sin square theta. So you will get your answer, or you are near to your answer, right? So assume that x equal to sin square theta. So again differentiation. So we can write dx equal to what? 2 sin theta. Again differentiation of sin theta. So cos theta and d theta, right? Now if you are changing the x, so obviously the limit is also supposed to be changed. So you need to find out what? Limits. So when x equal to 0 and x equal to 1, you have to find out what? Theta, right? So x equal to 0. So put here and find out the theta. So you will get what? 0. When x equal to 1, at that time you will get a theta, that is what? Pi by 2. Now the x equal to sin square theta and the limit just put into this basic equation. So you will get what? Beta mn equal to integration 0 to 1. So 0 to pi by 2. Now x raised to m minus 1. So instead of x sine square theta, m minus 1. 1 minus x. So 1 minus sine square theta raised to n minus 1 dx. So instead of dx you can write what? 2 sine theta cos theta d theta. Right? Now we'll solve this equation. This 2 is a constant, so we can write here 0 to pi by 2. Sine square theta. So this square, this power will be multiplied with this one. That means if you are writing like x raised to m whole raised to n. So you can write down what? X raised to mn. Same like that, sine theta raised to 2m minus 2. 1 minus sine square theta, that is you know cos square theta. So cos square theta. So again we'll write what? Cos theta. That square will be multiplied with this. So 2n minus 2. This sine theta cos theta as it is. And d theta. Now again simplify this one. Sine theta raised to 2m minus 2. And here also you have sine theta. That means sine theta raised to, we can say a 1. And cos theta also raised to 1. So when these are the same, you can add the power of that, right? So you will get what? 2, 0 to pi by 2 sine theta raised to 2m minus 2 plus 1. So you will get what? 2m minus 1. Same with the cos theta. 2n as it is minus 2 plus 1. So you will get what? 2n minus 1 and d theta. Now just check with your result. 2, 0 to pi by 2 sine theta raised to 2m minus 1 cos theta raised to 2n minus 1 d theta. So that is our third property. So this is all thing about what? Beta function and its property. Now in next lecture we'll go for what? Gamma function and relationship between beta and gamma function, and also we'll try to solve some example. Thank you for watching this video.